Hello and welcome to a video saying how to make a graph in Google Sheets. There was another one for Excel if you would like to use that. In general, most of my labs ask you to make graphs. This video is going to tell you not only how to make a graph in Google Sheets, but how to make sure you get full credit for it, everything you need, and also what the hell it all means and what is the point. So, in general, with graphing, most of the labs, as I said, will require graphs. They must be made in either Excel, Google Sheets, or another computer program. This video is Google Sheets. The other one is Excel. I don't have videos for other programs because I don't have other programs. If you would like to use something else, you're going to have to figure it out on your own. But as I said, this will show you how to get full points. Now, in general, when you make a graph, all the information must be obvious. You have to be able to look at a graph, see exactly what it is, see exactly what it's going for, and exactly what the point is. Everything must be labeled and clear. Now, I will always ask you to graph y versus x. I don't say y versus x, but I'll say something versus something else. Your graph may say graph f versus a, or graph p versus t over v. Or in this case, graph m versus x, where m is mass and x is distance. When I tell you to graph m versus x, what that means is that whatever comes first, that's your y value. Whatever comes second, that's your x value. So if I'm graphing m versus x, m is y, x is x. And it's kind of nice that x is x, makes life easy. Now, traditionally on a graph, y is your vertical, x is your horizontal. That means your y value should always be upright. So in this case, m should be on the upright. What you're going to do is you're going to have some data. You're going to probably have a whole thing of data sheets. But in reality, all you need is your data you're graphing to enter into the computer. If you have a large table, you only have to enter the data you're graphing in the computer. And what you're going to want to do is graph the things you're graphing. Sorry, what you want to do is input the things you're graphing. If it's m versus x, that means your m and your x. Now, I recommend always put your x data first. Since, as I said, x is x, that's going to go first. And I'll put my y data after. So what I'm going to do is I'm going to enter that into Google Sheets, which I already did. Now, to make a graph in Google Sheets, it's a little more complicated than it is in Excel. And I'm going to switch me down this kernel. What you're going to need to do is you're going to have to start, well, by putting the data. But once you have the data, select it all and hit Insert and go to Chart. When you go to Chart, this thing should pop up. Oh, that's not normal. Should pop up over here. Now, this went straight to a scatter chart, which it doesn't always do. But this is what you want, a scatter. If it does not pop up straight to a scatter plot, you'll just scroll down until you find scatter. In this case, it's right there. But make sure you find scatter chart. This also went straight to labeling the units, labeling the axes. That doesn't always happen. Often when you come up, it'll look like this. I'm going to delete the labels, even though they're already there. And they were there because I had them entered up here. That's why. But if they aren't there, I'm going to show you how to add them. Now, I made that go away. If you double click on a graph, this chart editor will come back. For labeling your axes, because it's important, you have to know what the axes are. What you're going to want to go is to chart and axis titles, and you can type the stuff in there. My horizontal is my x data, which, as I said, in this case, is x. So I'll just go horizontal and type it in and press enter. My vertical axis was m parentheses kg. So I type that in and press enter. Note I'm including my units. Always include units. The title can really be whatever. Chart title. Right now it made it this. I mean, a lot of times you may just want it to be like part A. I'm not too serious on what the title is. Now this is a good looking graph. The x and the y axis, or the y and the x axis, both have everything labeled, and you can see exactly what is being graphed. And you get points in a nice straight line, but it's useless as is. It doesn't tell me anything. It's just like, cool, dots. See, I want to get data out of this graph. And so what you're going to do is you're going to go and you're going to need to connect the dots, basically. You're going to go down to here where it says series. And once you go to series, at the very bottom is a checkpoint for trend line. When you click the trend line, it connects the dots. Yay, there's a line. But that line still doesn't say anything. It's just a line. So after that, go down a little further to where it says label. And where it says label, click it and hit use equation. And what that's giving me is the equation of this line. It says that the equation of this line is 0.982 times x plus 8.6 times 10 to the negative fourth. This is the correct graph. This is what you can put. Both axes labeled and a nice equation for our trend line, plus the trend line. That's what you'd want to give me. Now the question always becomes, cool, you gave me that. What the hell does that mean? Because I mean, this isn't immediately obvious. Now, let's go back to this PowerPoint. This is 0.0009, where this guy's was 8.6 times 10 negative 4. That is the same thing, just scientific notation and rounding. It's because I took them from different spots. The other one's from Excel, to be honest. What it gave you is this equation, this y equals 0.9823x plus 0.0009. That's the equation of the line. You see, for any line, y is the slope times x plus the y-intercept. What that means, well, first off, forget what that means. You never need the y-intercept. That 0.009 or 8.6 times 10 to the negative 4, whatever it was, don't worry about that. You never need it. But we know y is the slope times x. Therefore, 0.9823, that's the slope. That's the slope of our graph. And I always say, like, what is the slope? You just take that thing and put it in. Do not put the equation of the line. Do not write y equals 0.9823x. Just put 0.9823. You need a little bit more than that, though, because slope does have units. The units of a slope is always the units on y divided by the units on x. The units on y was kilograms. The units on x was meters. And so the slope will be kilograms per meter. Now keep in mind, that means x times 0.9823 kilograms per meter is m. Or x times 0.9823 kilograms per meter is y. It's the same thing in this case. Now what that 0.9823 kilograms per meter means is I always give you a physics equation to relate it. In this example, I might tell you that m equals k over g times x. That's just from physics. That's not from any of this math. That's just physics. I'd have to give you that. So we know x times k over g is m. But because of this line, we know x times slope is m. And therefore, if x times something is m, those pieces have to be the same. If x times slope is m and x times k over g is m, that means the slope must be k over g. Now, I always give an equation that looks like slope equals something. And you're never going to use that equation. That's not how you get the slope. You get the slope from the graph. Like, that's the only way you get the slope. But I'm always going to ask you to solve for something. In this example, you'd be solving for k. And if you wanted to solve for k, what you could do is say, okay, if slope is k over g, if I multiply both sides by g, that means k equals slope times g. And what you do is you take the slope of your graph, 0.9823 kilograms per meter, and simply multiply by g. And that's your value of k. And that's how you use this information. Now, if you're in physical science, feel free to sign off there. That is all you would need to do. But if you have me for physics 1 or physics 2, I'll also ask for the uncertainty in slope. And so for the rest of this video, I'm going to say how to get the uncertainty in slope. Once again, physical science people, sign off. You're good. If I want to get the uncertainty, I'm going to have to use something called the linest function. How you're going to do that is you're just going to click a square that's empty and type equal sign, L-I-N-E-S-T, open parenthesis, and it kind of gives you hints on what you need to do. Notice it says known data y. You just click and drag over your y values. Then hit comma. Then click and drag over your x values. And hit comma. And then it has calculate b. Just type the word true. Comma. Verbose, I'm not even sure what it means, and it says in there, but I don't feel like reading it. Just type the word true. Close parenthesis and press enter. And a whole shit ton of stuff shows up. Now, most of this isn't needed. In fact, just to annotate, you don't need anything here. You don't need this. You don't need this. You don't need this. You only need these two boxes. Now, the upper left one should look familiar. That was the slope of the line. That's the slope. The one beneath it is the uncertainty in slope. And that is what you're going to need to use for uncertainty in slope. Now, my picture, when I go back to the PowerPoint, is not going to have all the boxes going down, but it's going to have at least the two of them, the 0.982 and the 0.00969, right? That's these two right here. So, open. There we go. That is your slope. That should be the same as the value on the graph. Feel free to use that. But this other one is the uncertainty in slope. When you use the uncertainty in slope, that means the slope is 0.982 plus or minus 0.00597, if I want to be more precise. I rounded one off, kilograms per meter. Note, the uncertainty in slope has the same units as slope. What that means is your slope is anywhere within a range of values. Everywhere from 0.982 plus 0.0059 to 0.982 minus 0.0059. But that's not what I'm going to ask you for. I'm going to give a spot that says uncertainty in slope equals in a blank. And the answer is you just put the value. You just put 0.0059 along with the units. The units on Y divided by the units on X, kilograms per meter. That will be the value. The symbol for uncertainty is sigma. So if I want the uncertainty in slope, I'll say sigma slope. And you just put it in. What you're going to use is use that for an equation to find the uncertainty. We were solving for K, and so I'll give an equation for the uncertainty in K. In this case, the uncertainty in K is the uncertainty in slope times G. And you just take it, and that 0.0059 kilogram per meter multiplied by G, and that'll give you the uncertainty. Now, hopefully that'll help a bit. That is the process. If you have any questions, please come to my office hours or email me or whatever. I'll gladly help. I want you to know how to do this. I'll help as much as I can, but hopefully this was at least somewhat helpful. Good luck.